Assalamualaikum and a very good day I wish to everyone. So today I would like to present on the FYP poster entitled Mobile Augmented Reality Application Improves Performance in Programmable Logic Controller Experiment. So I'll start off with the abstract. Laboratory experience is beneficial in engineering education since it allows students to structure and conduct actual experiments, which help them to develop their particular aptitudes and skills. However, the students often encounter difficulties when dealing with complicated laboratory equipment, causing a longer time consumption in completing an experiment. So this study aims to determine how mobile augmented reality application um, affects student laboratory abilities and learning methods and also learning motivation based on the effective results. This case study validates the effectiveness of utilizing AR through a questionnaire-based survey in which students rated at the end of the experiment. Besides, this study provides a comparative analysis in terms of the percentage of improvement, POI, by using the data of task completion time, error counts, and the number of hints that are obtained from paper-based and AR-based instruction experiments. The study also provides the assessment of the understanding of mixed reality application using Microsoft HoloLens tool. The findings of this study suggest that AR and also MR are suitable technologies to be implemented in engineering education as the technologies are efficient and beneficial to students. This study shows that 91% of the participants preferred the AR-based method compared to the paper-based method. So next is the objectives. So there are a total of 4 objectives. First one is to develop an augmented reality AR application for PLC laboratory work using smartphone. Second is to develop a mixed reality MR application for PLC laboratory work using Microsoft HoloLens 2. Third one is to evaluate the effectiveness of the developed AR application for the PLC laboratory work. And the last one is to access the understanding of mixed reality application using Microsoft HoloLens 2. Next, we move on to the methodology. So to do this project, we need to identify the problem statement. And next, we have to determine the concept of augmented reality and mixed reality in laboratory. So I chose the PLC experiment. And next we have to develop the 3D model in SolidWorks. And after that is importing the 3D model into Blender. And after that, we need to develop the AR and also MR application. So it is divided into 2 sections, which is the development of the AR. And for that, testing needs to be done. And also AR application implementation also need to be done. And these steps represents the objective one. And also the development of the mixed reality application represents the second objective. And for the AR, after we develop the AR, we need to do a evaluation of the effectiveness of the developed AR. So that represents the third objective. And for the MR application, we need to do an assessment on it. So that will be objective number 4. And next, we move on to the results and discussion. So as you can see here, figure 1A and also 1B shows some of the scenes that are available from the AR application. So figure 1A is the wiring assembly of the AR application. So you just need to like connect the wires correctly. And this figure 1B is a scene from the AR application. And next is figure 2 show the assessment of the MR application using HoloLens 2. So figure 2A is actually the view of the MR application from the user's perspective. And figure 2B is a picture of a participant testing the MR application using the HoloLens tool. So next we move on to the results of the evaluation of effectiveness of the developed AR. So here you see is the data analysis for that objective. So the first figure 3A is shows the TCT using the paper-based is higher compared to the AR-based method. And for 3B shows the error counts made by the participants are much higher using paper-based method compared to the AR method. And figure 3C show the number of hints provided for the paper-based method is higher compared to the AR-based method. And the last one is figure 3D. So figure 3D shows that 91% of participants preferred the AR-based method compared to the paper-based method. And as you can see in table 1, it's actually the results of the percentage of improvement POI of AR-based instruction. So I took the data of all the three variables listed here, TCT, error counts, and also number of hints. And the POI that I've obtained is 58.24% for TCT, 17.13 for error counts, and last one 92.63 for number of hints. And next is the survey analysis. So as you can see in this table over here, there is a significant difference in the means of the AR-based method and the paper-based method, especially in section A and also section C. However, in section B, the means are not really that different from each other, maybe because of the participants, some of the participants still prefer the traditional way of learning, which is using the paper-based method. And next is the application. So there are a total of 2 applications. The first one is to simplify complex assembly process and ease troubleshooting through visualizing the workflow, especially in the manufacturing sector. And the second application that we can use by using AR and MR is help in bringing a product to life, especially in the area of product development. And next, we move on to the Sustainable Development Goals, SDG. So using AR or MR helps in achieving goal number 4, which is the quality education. So this SDG is one of the 17 Sustainable Development Goals, SDGs, that is created by the United Nations, which ensures all students to have access to high quality, inclusive education, and also encourage lifelong learning. And this SDG can be achieved by examining the challenges, possibilities, and advancement made in implementing ICT in education, concentrating on AR and also MR environments and the potential in the classroom. And the last one is conclusion. So the first conclusion that I can make is an augmented reality AR application for PLC laboratory work using a smartphone was developed. A mixed reality MR application for PLC laboratory work using Microsoft HoloLens 2 was developed. The effectiveness of the developed application for the PLC laboratory work was evaluated. And the last one is the understanding of mixed reality MR in Microsoft HoloLens 2 was assessed. All right, that is all from me. Thank you.